Good evening and welcome to my new Colorado shop. I had to take a sabbatical for about a year while I retired and helped move my wife and myself to the mountains here. And we built a new shop addition to the house, and we're in it. And tonight we launch again our hobby, and we have our first item up for review. And this would be a B&K 1805 80 megahertz frequency counter. We're going to demonstrate its capabilities. We're going to check out its function, its accuracy. It's been calibrated. We're going to compare it against our standards. So bear with me. We'll get going. All right, well, let's just take a look at this B&K 1805. It's an 80 megahertz frequency counter with the on-off switch. We have range switches, kilohertz or megahertz. We have a period switch. We can measure the period of the incoming frequencies. We have totaling, so we can measure and total up the pulses emitted by something for a period of time. We have our resolution switches, so we update at a frequency of 100 times a second, or 10 times a second, or once a second, or once every 10 seconds, tenth of a hertz. And we have a reset button, a hold button to hold any counter that you'd like to hold on there. We have a filter that we can kick in. And then we have a ×1 ×10 attenuator. There's an overflow indication that shows up on the left-hand side if overflow happens. And on the right-hand side, we would have a dot that would indicate kilohertz, megahertz, or in a case of period, microseconds. The unit is in very nice condition. No scratches to speak of on the case. Show you the underside here. Oops. Try to do everything with one hand. Okay. The underside, and then the interesting thing about these units is that they originally used an irregular 3-pin oval type plug, similar to an HP oval, but not an HP oval. Wasn't a standard, and they're difficult to come by, and quite often the cords run as much as the frequency counter. So to alleviate that problem, I machined this case and installed a standard computer type 3-prong 10 amp socket, and then we are using a standard computer cord. So you won't have to worry about having that problem, and you won't have to pay for it. All right. Very nice unit. By pulling out on these side pieces, you can change the tilt position of the unit. The stand can be swiveled underneath or up on top or behind. These handles, I'll warn you, they're sturdy, but they're not going to take a great deal of damage. I mean, you drop one of these things on the floor and the handle is likely to break somewhere up around in this area. So you have to treat it with care, but as far as normal usage, no problem. Okay, well, what I first want to show you is that I have my rubidium source, 10 megahertz source on. The green lights indicate that we've achieved lock. And as indicated on the Philips counter here, we have 10 million 0.0 hertz. So we are dead on right now on our Philips, and I have a 10 megahertz master oscillator on the bench that I normally run with because I don't like to run this rubidium too long. It has a fixed lifespan. Let's plug the master oscillator into the Philips. Give the Philips a moment to figure out what that frequency is. I'm going to go ahead and turn off the rubidium. Alright. We are on a 10-second cycle right now so that we can actually read our frequency down to the 10th of a hertz at 10 megahertz here. So we'll go ahead and turn off our scope. Okay, and once again we're seeing 10 million. Looks like right to the 10th of a hertz. So our master oscillator and our rubidium are agreeing very, very closely, which is good, because now I intend to use that master oscillator to test out this B&K frequency counter. Okay, so we are on megahertz right now. We could go ahead and put it into kilohertz, and we should see that in kilohertz we have 10,000 kilohertz, which is 10 megahertz. And the nice thing about this particular range is I am refreshing once a second, so don't have to wait 10 seconds for the refresh. So we're accurate. We're doing a great job right now. Now the thing to bear in mind here is I keep my shop at about 65 degrees. Pretty easy to do here in the mountains. I just heat it a little bit. And I gave the unit a couple of hours of warm-up time and then gave it a good calibration at that point. And just a steady hand, nothing, don't try to be too quick about it, just a very slight nudge will get you several hertz change on this thing. So if you ever go through a calibration on it, calibration hole is on the underside of the box. You can see the calibration hole there, and the trim capacitor is underneath the hole. Reach down in there with a tuning wand. In this case I use the smaller end, and then you give the thing a little tweak. Alright, let's go ahead and have some fun with this and take it through some paces and see how we do. I'm going to hook it up to my PTS 500, and we'll put some frequencies to it and see how we measure. I'm going to try and put it in a position here where we are closer to the PTS and we should be able to see it better. And I'm going to dim the lights again, turn on our desk lamp. Okay, so we're showing the 10 megahertz signal from the PTS 500, and we are going to go ahead and change the frequency then to 20. Oh yes, we are in kilohertz right now. We're going to change to megahertz because we've gone over. So now we're reading 20 megahertz. Yeah, let's change our resolution. So it's 20 million hertz within a 10 hertz. Let's go 30. All right, there's 30 megahertz. 40. 50. 60. 70, 80. All right, now 80 is the rating on this device. That doesn't mean it won't read more. It just means that 80 is within its margin of error. Alright, like right now I'm at 90. I didn't change my amplitude at all. Let's try 99. Alright, 99 it's not doing. So 98, 7, 6, 5, 4, 3, 2. Alright, so I'd say 92 megahertz is the upper limit of this unit. That's not bad. That's 12 megahertz better than it's stated. Alright, then let's take her down. And right now we're reading 1 megahertz. We can read 900,000. We can go ahead and give ourselves more resolution by going to the kilohertz. 900 kilohertz. Within 1 or 2 kilohertz. 800. 700. Alright, we're starting to get to the limit of my PTS 500 here. There's 600. Anything below 500 kilohertz, it starts to get a little flaky. So we're going to switch over. There's 500. We're going to switch over to do our low frequency measurements, and we'll use this Hewlett-Packard 3320B, which is a nice machine for lower frequencies. It does have a fan whir. Alright, we've dialed in 5.5 megahertz, 500 kilohertz, and we are reading 500 kilohertz. We should go 400, 300, 200, 100, and let's change our there's 90, 80, 70, 60, 50, 40, 30, 20, 10. We are definitely into the audio right now. There's 9. 8, 7 kilohertz, 6, 5, that's our heater kicking on in the shop here, 4, 3, 2, 1, this is 1 kilohertz. 0.9, that's 900. 800. Now let's skip down to 400. Let's go to 100. Okay. And there's 90, 80, 70, 60, 50, 40, 30, 20, 10, go to 2. There's 2. 1. So looking at this, I'm going to call our low frequency end about 2 hertz. So I'm not getting a reliable 1. So I'm getting a solid 2 hertz when I apply 2 hertz off of my frequency synthesizer. So this unit is capable of doing down to 2. The frequency response for the 1805 is stated from 5 hertz to 80 megahertz. So we've exceeded both ends of that range. While we're here, the period measurements are good for a period of 5 hertz to 2 megahertz. So let's go ahead and we're here at 2 hertz right now. Let's change the period and let's okay, so we've got period selected and our resolution is at the 100 hertz rate, and we are seeing about 500,000 counts, which at 2 hertz would be about right. 3 hertz we should see about 333,000, and at 5 hertz we should see about 200,000. And there we go. Let's go to the other end of the spectrum. Let's go to a megahertz. Alright, and let's change our resolution down a little bit. So right now we're getting about 1.000 microseconds. 1 microseconds would be for 1 megahertz, which is what we are set at on our dial here, is 1 megahertz. So our period is working fine. We can go to 2 megahertz. That's supposed to be the upper limit, and we see 0.500. You can, I think we can drop down. Yeah, we can drop down one more range and get just a little more resolution there. And if we were to go to totalization, not sure at this speed how we're doing. Yeah, we're totalizing, but it's way too fast. Let's try a much slower speed. There. And we can reset. Start to count over. Let's see if I was to make this a kilohertz. Make that 0.1 kilo. This would be 100 hertz. And this would be 10 hertz. Reset. Start counting at 10 hertz. But the totalizer is working too. Let's try the hold. I just pushed the hold and we held at 172. If I lift the hold, we should start counting again. It was counting in the background, so it picked up where it left off. So there you have it. I think we've pretty well demonstrated the capabilities of the unit. Let's close out here. Okay, so that was the introduction to the unit. Nice looking. Along with the unit, we get the new cord, and we'll include a manual. Manual takes you through a number of worthwhile steps. Talks about test instrument safety, goes through the specifications, the controls and indicators, operating instructions, safe frequency measurements, period measurements, display interpretation, totalizing measurements, general considerations for usage, goes through the circuit description, block diagram analysis and schematic diagram analysis, maintenance and calibration, case removal, line voltage conversion, fuse replacement, some troubleshooting, circuit boards. Then it goes through some frequency and period tables. So it's a very complete manual. Together they're a nice team for your bench. Thank you for listening, and happy bidding, huh?